Hello my fellow causal champions, my name is Anne Sinclair and I'm your host today on Causal Discoveries. We are continuing this series investigating the theory of universal specificity, which directly challenges the venerated theory of relativity. Please hit that subscribe button below to keep up to date as episodes in the series are released. You may recall that earlier in this series, Dan Harris, our last host, made the bold claim that relativity is to the geocentric planetary model as universal specificity is to the heliocentric planetary model. He then outlined 5 parallels between Kepler's work on validating the heliocentric over the geocentric model to his work on validating universal specificity over relativity, which will be covered in this series. Last episode, he partially covered the 3rd parallel, where special relativity led to a contradiction that could only be resolved if an assumption contrary to relativity's base assumption is correct. Check out these earlier episodes linked below to get the full discussion if you haven't already. In this episode, we have a guest speaker lined up to help me cover the 4th parallel, which focuses on a new causal discovery, the cause of kinetic time dilation. I hope you enjoy this episode on causal discoveries. You may be interested to learn that gravitational time dilation that exists around massed objects, and kinetic time dilation were once thought of as 2 separate phenomena until our next speaker united them. Our next speaker will be discussing the first steps toward that union. This is the first step where universal specificity really takes off and departs from Lorentz Ether Theory. Please help me welcome our next guest, Dan Harris.
Oh, thank you. I'm happy to be here, Anne.
To begin, please explain to our audience how universal specificity deviates from Lorentz's ether theory.
Happily. First, you must realize that Lorentz Ether Theory made the same mistake as relativity. It assumed something about the speed of light, then proceeded to derive a physical model based on that assumption and validate it by means of verifying its predictions that correspond with reality. And as we've seen from history with the planetary models and now relativity, causal discoveries in physics cannot be done this way. It might allow us to derive a useful model that makes fairly well predictions, but that model may still be incorrect in its explanations for why those predictions happen. In the case of the Lorentz Ether Theory, it assumed the existence of an ether, or a medium in which the light propagates, and that light is constant in this medium, much like sound is constant in air for the speed of sound. And so it may well describe what we see, but its reasons why we see it, namely the existence of an ether, may be false.
How does universal specificity go about this?
The approach taken with universal specificity is to follow the evidence and only the evidence. Go as far as the evidence proves and no further. Avoid making any guesses as to the underlying causes for observations without scientific evidence. Guessing there is a medium in which light propagates is a good guess, since light exhibits wave-like properties, and other waves we know about propagate in a medium and have a constant speed relative to that medium. However, the biggest glaring difference in light's case is that unlike other waves, we cannot measure anything about space like we can measure about other wave mediums such as air with pressure and temperature. And so as far as we can measure, space in which light propagates is literally nothing. So for universal specificity, accepting the existence of an ether is too much of a leap.
Alright, so the difference between Lorentz's ether theory and universal specificity is that Lorentz's ether theory postulates the existence of an ether to explain why light is constant only in a single inertial frame, while universal specificity starts with light is constant only in a single inertial frame for some reason yet to be determined?
Yes, exactly. Additionally, another difference is that the Lorentz Ether Theory doesn't properly address the contrary assumption made by relativity, as is done by universal specificity. Recall from previous videos in this series that the relativity of simultaneity is a consequence of relativity's light postulate, and it creates a contradiction where 3 inertial frames with the same definition of present or now can simultaneously claim that event B comes before, during, and after now, which means that the light postulate cannot be true since contradictions cannot exist.
Great. Can you tell us what causes time dilation?
Easily, specific work done to objects cause time dilation to objects, where work done is relative to the one frame where light is constant, which I call the universally stationary frame, since absolute motion across the universe is relative to this frame.
Let's begin to unpack this for our audience. What do you mean by specific work?
Well, to begin, work is some amount of force applied over some distance, and specific work is work, but scaled by an object's inertia. Inertia being an object's resistance to change in motion. So the more inertia an object has, the more force that is applied over the same distance to achieve the same change in motion compared to an object with less inertia.
Okay, why do you say time dilation to objects when time dilation is considered something that is part of space-time?
Well, keep in mind, special relativity was just proven wrong, which doesn't necessarily mean concepts based on relativity are false, as it does in this case, but it definitely means that at least we need to reevaluate them to see if they can be based on something that isn't false. So in this case, space-time doesn't actually exist, and to truly understand what time dilation is and why it affects only objects, we need a better understanding of what time is and what is happening when it dilates.
Alright, that's why we're here. Let's dive in. What is time, Dan?
Well, Albert Einstein once defined time as that which clocks measure. So this definition is simultaneously true and useless. He was probably trying to be funny because it's obviously a circular argument. It begs the question, what is being measured? But I think his point was probably it's a tough question to answer, even for him. The best definition that I found is time is an interval over which change occurs. And to determine if this definition captures the essence of time, one must ask, what facts of reality give rise to this conception of time?
What facts are those?
There are basically three. This one I maybe call fact zero because it stands to reason that if nothing changed, if nothing moved, if light stands still and everything else stood still, there'd be no time, there'd be no passage of time, nothing would change. So change is very important. And to understand the two facts about change, one, it's not instantaneous. No change is instantaneous. A thing in state A cannot change to non-A instantaneously. Otherwise, it would be in both at the same time, which is a clear contradiction and impossibility as dictated by the law of identity. The second fact about change is given the same essential conditions, the same change will occur over the same interval as dictated by the law of causality. In fact, if this interval of change were to change, it suggests that a change also occurred to the essential conditions. So these two facts about cause, or changes, give rise to the need for such a conception of time because it bestows upon its user the power to gain causal control over certain factors. For instance, it is what allows us to reasonably expect that raw food would be cooked well to the desired effect at the end of a certain duration, or burnt if cooked much longer. And it allows us to establish a meeting at a certain time, which is the desired effect. And despite the variety in our busy lives, people can come together to achieve a common objective at these meetings. So this conception also explains why certain things do better as timepieces than others.
Oh, why is that?
Well, since time is the interval over which change occurs, it means good timepieces are those that undergo regular periodic changes. The more regular, the better, and the shorter the period, the better. If one looks at what has served as timepieces throughout history, one sees this pattern emerge, going to more regular and shorter periods. So, for example, the periodic motion of the sun was used to measure days. The periodic shift of shadows throughout the day was used to measure hours and like a sundial. Sand falling through an hourglass can be used to measure minutes to an hour. Pendulum swinging and grandfather clocks can be used to measure seconds. or light traveling a known distance can be used to measure a nanosecond, or 1/1000th of a second. So each of these instruments use periodic, regular changes to measure an interval over which change occurs, which is what we call time. So any other non-regular or possibly non-periodic change can be compared to one of these instruments to determine how long it took for this irregular or non-periodic change to occur.
I see. So these invariant timepieces serve as the standard for measuring time.
Exactly. But recall fact 2 about change from earlier, that under the same essential conditions, the regularity of these changes will remain constant. That is why the regularity of these timepieces remains constant, but only if the essential initial conditions remain unchanged. In fact, any change to the regularity suggests a change in an essential condition assumed by the timepiece.
Does that happen? If so, would you give us an example?
Oh, sure, of course. And it happens quite often, actually. So if you just take a grandfather clock or an hourglass as an example, without proper calibration, the interval over which the pendulum swings or the sand falls lengthens if the device were taken to a higher altitude, and shortens if it were taken from like a high altitude to a lower altitude. And this example is actually what begins to allow us to understand what time dilation is and why it only applies to objects.
You mean to suggest time dilation is a change in the interval over which change occurs?
Precisely. And more explicitly, time dilation is a change in the interval over which change occurs to things, as opposed to the invalid concept where time dilation is a rotation or a bending of space-time. So this concept of time as an interval over which change occurs has no place for space-time. It is out.
So, time dilation has nothing to do with space-time rotating or bending.
The space-time concept and the rotating or bending is a handy math trick to help predict observations. But no, time dilation actually has nothing to do with space-time bending. There's no such thing as space-time in existence, or time as some property of the universe independent of the changes to objects that make up the universe.
I see. And I agree. Thank you for that illustrative explanation of what time dilation is and why it only occurs to objects. With that understanding, how do you know specific work done to objects causes time dilation to objects?
My method of causal discovery is John Stuart Mill's method, which is first published in 1843, which explicitly captures the method used by Newton to discover his laws of motion and gravity, first published in 1687. The methods commonly used today are not these. They're used sometimes, but seldom. So if one is not a student of history, one might prematurely conclude the method I use predates the modern methods used today by some 300 plus years. And so the modern approach used commonly today is to guess as to the reason of an observation, derive a model based on these guesses, and compare its predictions with observations. Now, an astute member of this audience would know, if they watched the first episode of the series, that this modern method is the same method used by Ptolemy, who died in 168. So he used this method to derive his geocentric planetary model. So this really means is the modern method that is in common use today predates the method I use by 1,500 years. It's literally pre-enlightenment. So in using Mill's method, what I did was I listed the plausible causal factors and tested each one in a controlled experiment until the cause precipitated out for the rest.
Dan, can you briefly list the plausible causes of time dilation you tested?
Sure. The plausible causes for time dilation were relative velocity between two objects, velocity relative for any object relative to the universally stationary frame, during acceleration, work done, and specific work done. So those are the 5 that I tested. And so relative velocity was plausible because it's in the original time dilation equation derived from special theory relativity. Velocity relative to the universally stationary frame is plausible because it's basically the same as the one derived from theory of relativity, but it's derived from Lorentz Ether Theory instead. Acceleration, which is that time dilation only occurs during acceleration, is plausible because in the twins paradox, the accelerated twin is the one that ages less. And work done and specific work done are plausible because, this is relative to the universally stationary frame, but it's plausible because it causes all the rest. So there you have it. Those are the plausible ones that I tested.
I see. Briefly, please explain Mill's method.
Of course, I used two of his methods, the method of difference and the method of agreement. The method of difference is where two experiments are conducted, and the effect is present in the first but not the second experiment. The effects differ, thus the name, the method of difference. The list of antecedent factors in the first case, which are not present in the second case, are the list of plausible causes. So, for example, if I flip the light switch off and the light turns off, then the switch being switched off, which it was, on in one state, the light's on, off in the other, that's the cause of the light turning off or on, because it changes with the effect. So the method of agreement, on the other hand, is where two experiments are conducted and the effect is present in both experiments. The effect agrees between the experiments, thus the name, the method of agreement. So the list of antecedent factors common in both cases are the list of plausible causes. So for example, if several students contract some food poisoning after eating cafeteria food, as an example, and the only commonly consumed food item was, let's say, coleslaw, then the coleslaw caused it. So both methods can be used together to narrow down and whittle down the plausible causes until one remains. And so my approach was to consider thought experiments that ruled factors out until basically one cause of time dilation remained.
So why does this method work?
That is a great question and far too seldomly asked. Basically, it's the application or the recognition of the law of causality. So the law of causality is the law of identity applied to action. So for those that don't know, the law of identity states that a thing is what it is. To be something specific. And so this means a thing which currently takes on some form has the potential to change into another form consistent with its identity. And this change from one form to another is the action taken by the entity. And given the same essential conditions, the action a thing takes is always the same. And that's the law of causality. So an ice cube always melts at room temperature. The time it takes your coffee to reach room temperature is always the same, given the same conditions, such as the cup it's in, and the environment the cup is in, etc. And Mill's method is a means of interrogating nature to tease out which conditions are essential. And that basically means causes the effect for the thing to assume a new type of form, which is the effect. So Mill's method is a means for a scientist to act in recognition of the law of causality to discover causes of certain effects.
What experiments did you use to tease out the cause of time dilation?
Tease out. I ran 4 thought experiments, 3 of which were methods of agreement, and 1 was a method of difference. And the sum of these demonstrated that specific work done relative to the universally stationary frame is the fundamental cause of time dilation. The first thought experiment that I conducted was designed to rule out relative velocity being the cause of time dilation, which is a remnant of the now falsified special theory of relativity. To demonstrate that relative velocity doesn't cause time dilation between two objects, I set up a situation where two objects started out in the universally stationary frame, traveled away in different directions, and returned to the same frame using the same speed profile. So their velocities were different, but the relative speeds to the universally stationary frame was the same. So And in this case, the amount of time that passed for the entire trip for each was the same. There's no dilation between. The time passage for each was the same. And so this is a method of agreement experiment where the effect remains constant, or the unchanged time dilation between the two objects that traveled and came back. But the plausible causal factor, relative velocity, could be any value whatever. You could set it to be zero. You could set it to be the speed of light, thus ruling out relative velocity as a plausible cause of time dilation. Now, can you guess, or do you know what plausible causal factors of the other four were present in this experiment?
I can see that velocity relative to the universal stationary frame, acceleration, work done, and specific work done could remain consistent between the two objects in this experiment alone. Does that mean they remain plausible?
Yes, precisely. Both objects had the same but opposite, in the simplest case, velocity profiles relative to the universally stationary frame. They both accelerated the same exact way, maybe in different directions, but their values of acceleration were the same, and each had the same specific work done. And if they had the same inertia, then they each had the same work done as well.
Wow, cool! Go me! What do your other thought experiments reveal?
Well, this second thought experiment is designed to rule out time dilation only occurs during acceleration. While it is true that in the twin's paradox, the twin that travels away from the other extremely fast and then returns ages less than the twin that stayed still, and the twin that ages less did accelerate, but acceleration seems to be the difference that makes the difference, but this is a misinterpretation of the data. Acceleration is certainly related, but this does not mean time dilation occurs only during acceleration. This formulation is not accurate or precise enough. So a thought experiment can eliminate acceleration altogether, yet time dilation still occurs, as in time, less time is recorded for the clock that travels away and returns. So in order to accomplish this, it requires 3 clocks. So one is stationary the entire time in the universally stationary frame, and 2 are set up so that they're initially moving before this experiment starts. So the pink clock is stationary, and it establishes the initial time the moment the moving green clock passes it. And so both green and the pink clocks are now synchronized at the same location at the same time. And so no acceleration occurred during this synchronization, and then both clock velocities remain unchanged, and they will continue to remain unchanged until the experiment is done. And so when the green clock is passed by the blue clock, which is moving in the opposite direction, another synchronization occurs, and so there's no acceleration that has happened. As soon as they pass by each other, the time it took the green clock to reach that point is transferred to the blue clock, and the blue clock continues to keep time from there. The blue clock then returns to the pink clock to compare the total time recorded by the moving clocks with the total time recorded by the pink stationary clock. And it turns out that the moving clocks recorded less time than the stationary clock, even though there was no acceleration during the entire experiment. And so this is the method of difference, because the time dilation for the stationary and the moving clocks differed. The effect, which is time dilation, differed. Yet acceleration remained 0 or unchanged. It was 0 the entire time for all of them. This means that the plausible cause cannot be the cause we're looking for. Time dilation doesn't occur only during acceleration. So what remaining plausible causal factors changed during this experiment?
I can see that the traveling clock's velocity relative to the universal stationary frame, work done to them, and specific work done to them to achieve that velocity is different than the stationary clock. Does that mean these factors remain plausible causes of time dilation?
Again, yes. The moving clocks had velocity relative to the universal stationary frame, while the stationary clock did not. Therefore, this could be the cause of time dilation. Also, the moving clocks had to have some work done or specific work done relative to the universally stationary frame to achieve the velocity they achieved in the past. And so, therefore, they could be the cause of time dilation.
Wow, go me again, I'm 2 for 2. What's next?
So up to this point, we've ruled out relative velocity and acceleration. This next thought experiment is designed to rule out work done as the cause of time dilation. So using Newtonian mechanics, we can ballpark some figures. Imagine some force is applied over half a meter to accelerate an object the size of a planet from 0 to, say, 50 micrometers per second. So, and this is relative to the universally stationary frame, so it's stationary and then moves 50 micrometers per second. Now, if that object was Pluto, our former 9th planet, then the amount of force necessary to achieve this in newtons would be like 650 times 10 to the 12th. Now, imagine this same force applied over the same half-meter distance to accelerate a 1.3 gram marble. Now, its final velocity would be about half the speed of light. And from this, we know that the time dilation for the marble will be much more extreme than the planet. And so this is the method of difference where the effects differ, the time dilation between the marble and the planet differed. Meanwhile, the plausible causal factor remained unchanged, meaning the work done to both was the same. Therefore, work done cannot cause time dilation. Now, what remains?
The remaining factors that changed in this thought experiment were velocity relative to the universal stationary frame and specific work done. Both changed in this case, so each might be the cause of the difference in time dilation between the marble and the planet, even if Pluto might not be a planet anymore.
Excellent. 3 for 3. I can see you've got a great mind for causal discovery.
Yes, thank you, but I'm kind of stuck on how one might separate velocity relative to the universal stationary frame and specific work done, since to achieve a certain amount of velocity relative to the universal stationary frame for any object requires the same amount of specific work done to it. They both change by the same amount for everything.
That is a great point, and actually a point that got me stuck for quite a while. And so this last thought experiment is meant to solidify specific work done as the fundamental cause. So take the same two objects as before, the Pluto and this marble, and apply the same specific work done to each, and they achieve the same change in velocity relative to the universally stationary frame, like you said. And we can see that velocity relative to the universally stationary frame is an effect of specific work done, making specific work done a more fundamental cause than velocity relative to the universally stationary frame. So when a cause creates two simultaneous effects, it's easy to confuse one effect as the cause of another effect, or one as the primary cause. So as an analogy, suppose your purpose is to become rich, and you are given two plausible causes to act on to become rich. One, make more money, and two, become more productive. Now, which serves as a more fundamental cause, and which is the corollary?
Why, being more productive is the fundamental cause, which also causes you to make more money, which is necessary in becoming rich.
Exactly. So this is how I determined that the fundamental cause of time dilation is specific work done. We can see that the time dilation equation relating relative velocity to velocity relative to the universally stationary frame is truly the effect of specific work done. If we replace the effect with the fundamental cause, then we can derive a causal relationship in mathematical terms. So this equation here for the dt prime, that's the rate change of time for an object moving relative to the universally stationary frame. The dt is the rate change of time for an object stationary in the universally stationary frame. And this velocity subscript USF is the velocity of the moving object relative to the universally stationary frame. C is the speed of light, and which is constant in the universally stationary frame. And so we can see that this v squared is really just twice change in the specific kinetic energy. And a change in specific kinetic energy is really specific work done, which is a specific force applied over some distance.
Wow. Impressive work, Dan. That makes a lot more sense now. V squared was hiding specific energy, it was specific work all this time, but why twice specific kinetic energy?
These are great questions. So, as it turns out, it's not truly twice, and this lingering 2 isn't there by coincidence. This 2 belongs with this inverse c squared there at the bottom, as in 1/2 c squared is a term for total specific energy. Therefore, c squared was really twice total specific energy this whole time. Or more precisely, the v squared over the c squared is equivalent to a change in specific kinetic energy over total specific energy. Now, I won't get into the details that for the mathematical derivation, but we can, if you're interested, you can check out the papers linked below for those that like mathematical derivations. But this 1/2 c squared is like the younger sibling of Einstein's total energy equation, where you remember E equals mc squared. But instead of total energy, total specific energy is what we're using, and it's basically abstracting out inertia from an object, or the object's resistance to motion. And so, like E equals mc squared, which is equal to these other terms, one of them is internal energy, the other one's change in kinetic energy, which is the full relationship relating total energy, internal energy, and change in kinetic energy. There's an equivalent relationship for specific energy, which is E equals 1/2 c squared equal to some other terms, which is specific internal energy and total or change in specific kinetic energy. And so this c subscript 0 term is the term we discussed earlier, which is the average effective speed of light relative to an inertial reference frame moving relative to some inertial reference frame moving in the universally stationary frame. And so there you have it.
Fascinating. Does this relate back to time dilation in some way?
Oh yes. All these new specific energy relationships relate back to time dilation in the following way. You see this equation here. This reveals an interesting causal chain of events that eventually leads to time dilation. First, specific work is done, which causes an object to speed up relative to the universally stationary frame, which causes the average effective speed of light to reduce relative to the moving object, which finally causes an increase in the interval over which change occurs to the moving object. The last effect is based on the fact that the speed of light is the speed of causality, where the rate of change relies ultimately on how fast light is relative to the object undergoing change. The faster the light, the faster the change, and the slower the light, the slower the change. So this remains consistent with the specific energy model. As you may have noticed, the total specific energy is a constant, 1/2 c squared. This means as the object gains specific kinetic energy, it loses specific internal energy. What could this mean? What is physically happening here? Well, time dilation means that the internal happenings of an object undergoing time dilation are slowing down. The duration of change is increasing. So this is why specific internal energy is decreasing. Taken to its limit, where an object travels the speed of light relative to the universally stationary frame, the object is frozen. It is no longer changing. The average effective speed of light in its frame is 0. Therefore, its internal energy is 0. And taken to the opposite extreme, where an object is at rest in a universally stationary frame, the internal happenings of the object occur as fast as possible. Therefore, the internal specific energy reaches its max potential, which is 1/2 c squared, while its kinetic energy is 0, or specific kinetic energy is 0. The only thing that's happening to the object is what's happening inside of it. It's not changing relative in terms of its position relative to the universally stationary frame.
Okay, just to summarize what we covered to make sure I understand everything and didn't miss anything. 1. We covered how universal specificity differs from Lorentz Ether Theory. Lorentz's ether theory assumes the existence of an ether as the cause for why light speed is only constant in the universal stationary frame, while universal specificity only acknowledges light speed is only constant in the universal stationary frame as fact, but makes no speculations as why it is fact. 2. We covered properly conceptualizing the nature of time and time dilation. 3. We covered that your method for causal discovery is Mill's method and is different from the modern method. The modern method is pre-Enlightenment. Using Mill's method, you constructed 4 thought experiments, which teased out specific work done as the cause of time dilation.
In a nutshell, yes, you've got it.
Wow. Thank you for your contribution to causal discovery, and thank you for joining me in this episode on causal discoveries. Dan Harris, everyone.
Thank you, and you're welcome.
Wow, what a whirlwind of fresh new concepts blazing a trail in causal discoveries. Yet, as we'll see, Harris has only begun. Up next, Harris, along with a previous guest, will be returning to help me complete the second and third parallels between Kepler's work on planetary motion and Harris's work on universal specificity. In this upcoming episode, the cause of time dilation will be used to derive a new gravity model, completing the second parallel. This will then be used to analyze general relativity, which will reveal another anomaly that can only be resolved if a contrary assumption at the base of general relativity is correct, completing the third parallel. Until then, you can review the status of this series production by referencing the WordPress link below, which captures the draft outline of this video series and the progress of its development. Don't forget to like, subscribe, and share if you enjoyed this episode, and please add your comments or questions below and let us know what you think of the cause of time dilation. I'm Anne Sinclair, and until next time, enjoy making causal discoveries.
Let's go. Yo, I'm like an addict, do I gotta have it. I ain't even playing, got a really bad habit. If it moves, gotta grab it, fuse like a magnet. Lose, won't have it till I'm doomed in a casket. I ain't playing, got a weird mind. If you work 8 hours, I'ma work 9. If the shoot tastes sour, you should taste mine. I'ma stay in power for a long time. Get up, nah, I ain't a quitter. Toss me the ball, I'm a really big hitter. Big picture, I'm a straight killer. Rising the song to the highest bidder. Got juice, got gas, I'ma move fast. New shoes, new tracks, like who's that? I'm new, come back, better than last. Yeah, it's a new me, never gonna look back. I'm never gonna look back. Cause damn, I was built to last. You move slow and I move fast, and that's facts.